Can AI turn a 10x developer into a 100x developer? I've given this talk at Entwickler Summit 2025 in Berlin, and because of the great resonance it received there, I've decided to record it to be shared more widely. Hello, my name is Paul. I am the CTO and co-founder of Express AI. I've been developing software for over 20 years. For about 10 years of that, I've also had a focus on machine learning and what media calls AI these days. So, can AI turn a 10x developer into a 100x developer? To be really able to answer the question, we first need to talk about what a 10x developer is. And then we need to understand how we want to extract another order of magnitude more productivity from that. Is a 10x developer someone who is 10 times more productive than their team? Or is it someone who is 10 times more productive than the average developer? And what is productivity in the context of software development anyway? Productivity is unfortunately not a simple topic when it comes to developing software. We can't just count how many pieces of product end up in the box at the end of a shift like we might with an assembly line worker. From my experience, it is often the developer who apparently produces the best code who gets this label. But even the question of what good code is can't be answered so easily. One quality of good code is pretty obvious. It must solve the problem. If it doesn't do that, then everything else doesn't matter. But that alone is not enough. We also want that code to be maintainable. We want it to be extensible. But in practice, these properties are also difficult to impossible to quantify. The good code for a microcontroller looks drastically different from the good code for a Java enterprise application, after all. And this leads us to a highly uncomfortable truth. If it's so hard to define productivity based on code, then maybe it's not about that at all. In fact, the code we produce day to day is actually much more liability than asset. The saying, more cheese means more holes, also fits software. More code means more bugs, more maintenance effort, more potential problems with extensions. Few of us jump with joy when we learn that we are supposed to work on a project with 1 million of lines of code. And oh yes, nobody from the original team is still around. Well, nobody except maybe those who get paid exceptionally well for it. And everyone probably also knows the story of the supposedly highly productive colleague who in hindsight mainly accumulated a lot of tech debt before switching companies. If code is not the valuable result of our work as software developers, then what is it? I say it's the understanding of the problem and the solution space, the mental model that we build. When the mental model and the implementation fit well together, then we have a solution that can often effortlessly adapt to new requirements. Maintenance and extension become easy, and the software can actually improve over time. Already 40 years ago, Peter Knorr shared the same insight with the world in an essay called Programming as Theory Building. And there, he explains to us that precisely this mental model can only exist in the programmer's own head. That is, because it is purely tacit knowledge, it cannot be completely transferred to a secondary artifact like source code or documentation. No matter how much you might write down, it is impossible to write down the entire mental model. This in turn presents us with another problem. How can we share this model with our colleagues? Ultimately, everyone on the team will have their own mental model. Through intensive collaboration and exchange, however, we can ensure that all these models are as similar as possible. Whether this exchange happens in formal meetings, in the hallway, through pair programming, or even by overhearing third-party conversations, plays almost no role. If you can say, for example, that the system works like a bakery, and everyone on the team understands the exactly same thing, then you have successfully established a shared mental model. When it comes to whether you can get a project finished faster by putting more developers on it, Everyone surely knows the saying that 9 women can't give birth to a child in 1 month. The reason for this is that more developers also means more communication. And this additional communication is necessary precisely because you have to re-establish consensus about the mental model. If you don't succeed, then the shared model can splinter into many fragments. Everyone then cooks their own soup. The consequences are then that the quality of the software decreases. Extensions and maintenance become increasingly more difficult. Peter Nurr says in his essay that this ultimately leads to the software being dead. When no one can clearly answer the why questions anymore, then the last piece of the original mental model has been lost. The software itself still runs. It can still do what it was supposed to do, but in this zombie state, it can only rot and get worse. You can try to reconstruct the model, but this is at best an archaeological project. You will only ever be able to answer the questions with probably because. After all, we can neither read minds nor can we time travel, and we absolutely can't do both at the same time. But Paul, what does all of this have to do with AI? Well, AI produces precisely this dead code at breathtaking speed. The core problem is that AI has no mental model. AI itself is just a probabilistic model. It produces things like a bracket is often followed by a semicolon, or hello is often followed by world. These days, it is a highly sophisticated probabilistic model. But still, there is no thought, there is no mind, and therefore there is no mental model. And for this reason, it is up to the user to articulate the relevant parts of their mental model to influence the probabilities just right, and then ensure that the AI code actually fits into the model. And this brings us to the core problem of AI in software development. A user without a good mental model creates new liabilities at considerable speed. But even if the user does have a good mental model, if they approach it with the AI knows what it's doing, or so far it's always been right, then you still end up with a fragmented model. The implementation and the understanding start to shift and desynchronize. You could obviously ask an AI, why did you do it that way? But the answer will have very little to do with the original reasons. All of this sounds like you'd almost have to be afraid that the 10x developer actually loses an order of magnitude of productivity instead of gaining it. Well, in my experience, AI can be used productively. To see how a developer can use AI and where to watch out for pitfalls, I'd like to shift gears a bit now and look at the different ways you can actually use AI in everyday development. For this, I've broken it down by autonomy and integration into the development environment, and thus got 4 quadrants. Chat falls into the helpline area. It's like the AI is a colleague in this case, that you would call if you have questions. They only work with the information that you give them, and you'll have to apply the advice manually. Tab completion and in-context prompting fall into the tooling area, because both are only possible through the strong integration into the development environment. The AI agents occupy the upper area with high autonomy. The IDE agents fill the pair programming quadrant, and terminal and remote agents can be thought to be more like outsourcing. Chat as an interaction model with AI surely doesn't need much introduction, as everyone knows something like ChatGPT. They are completely reactive and transactional in this case. If I have a question, I get an answer, and that's the end of it. This works well when I need to do some research, when I need a crystallization point for my mental model, or if I'm looking for additional perspectives to better understand the problem. But if you want to develop software with it, you quickly find yourself in a copy and paste workflow. This requires a constant context switching from development environment to chat and back. It's almost like having a Stack Overflow that has instant answers, only that it is missing the comments telling you, oh well, this approach no longer works in 2025. Tab completions probably won't be anything new to anyone here either. Even before the big AI hype, we had features for that, back then with other heuristics though. What's new now is that not only the next call, but the entire paragraph of code can be generated. If it is something trivial like a getter, setter, or the field initialization in a constructor, you can just accept it and move on. But if it isn't, it tends to drive me mad. I have an idea in my head, I'm right in the middle of implementing it, and code appears that might save me some typing. But now I have to assess whether that block of code actually fits my intention or not. Most often, it doesn't. But now my train of thought has been thoroughly derailed. It's almost like someone shouting numbers while you try to keep a count. For this reason, I've now started to turn it off everywhere where it appears. The funny thing is that the limited offline models offered for free in the JetBrains environments, precisely because of their limitations, do the job much better. They only suggest a maximum of one line, and they solve trivial tasks efficiently. Everything beyond that only helps the decomposition of the mental model though, because it literally shouts code in without having any of the necessary context. In-context prompting is basically the opposite to tab completion. Similar to chat, you also have to explicitly give a task description here. But because it is just as strongly integrated as tab completion, you can do this exactly where you want the new or changed code. And you have the possibility to directly reference other files or functions. The result is a div, not some blah blah. And it usually happens fast enough that only my own reading and comprehension speed slow me down. For the mental model and its implementation in code, in-context prompting is fundamentally solid, because you explicitly set the tasks and immediately go into code review mode, where you can also accept or reject changes line by line. You, as the user, are always able to bring in the necessary parts of the model and examine the generated code accordingly. The disadvantage, however, is that it's too locally limited. Refactoring cannot be done in one step if more than one file needs to be touched. Also, only Cursor has implemented this modality so well that I could actually really recommend it. With many other development environments that have something similar, the integration is not good enough that it would be worth it compared to other options. From the strongly integrated but little autonomous tooling options, we now come to the very autonomous but little integrated agents. Remote agents are probably the least known type of AI development agents. Strictly speaking, I would also classify vibe coding tools in this category, but they don't really see themselves as agents, so let's leave them out. The probably best known example in this category is GitHub's Copilot. Although the name is also used for the plugin in development environments, because Microsoft nowadays simply calls everything Copilot, I'm talking about the feature that you get on the actual GitHub website. And it works by assigning an issue to Copilot. And then sometime later, sometimes many hours later, a pull request is created and you can either accept it or comment on it if it doesn't fit. On one hand, that's quite nice because you don't have to block your own computer for it. But on the other hand, the distance also brings in the costs of context switching again. You can't just intervene when you see the agent is going astray. You also have to write particularly good issues if you want to expect useful results. This additional friction also leads to complacency. Instead of going for another round of comments to get things just right, we tell ourselves, oh, I'll just fix it later, and then accept the pull request as is. Terminal AI agents are currently on everyone's mind due to Claude Code. In this case, you have an agent running on your own computer. It uses just a terminal window and needs a folder to work in. You can and should watch the agent at work, and it will also ask you questions more frequently. You can configure how much of this should be automatically approved there. But some things you should never automatically approve, in my opinion, unless you run the agent at least in a virtual machine. I've already seen Claude delete all its work on its own. Despite being closer to the action, I still find the turnaround time to be too slow. A lot of time is lost on navigation and on triggering linters and compilers and processing their output. These time costs are also the reason why, in my opinion, you tend to more or less just wave everything through, and like with remote agents, only look more closely at the end. But because you've already accepted everything, that final review may not actually be that close anymore. And so the implementation and mental model drift further and further apart. With agents that are built directly into the development environment, we now also get back to stronger integration. At first glance, the whole thing looks as if you've simply built the chat into a side panel. But the ability to directly reference files or even functions and to make use of IDE features quickly shows the difference. Changes are shown directly in the editor, usually also as a div, so you can actually think about the changes in the appropriate context. The feedback loop is often similarly as fast as with the in-context prompting approach. But because the agent also can or sometimes needs to navigate, and it also tells itself a story about what it is doing, you are still using more tokens, and therefore it takes quite a bit longer than the pure in-context prompting approach. Nevertheless, I think this is where the sweet spot really lies, because I, as the user, am still very close to what's happening. I can bring in my mental model and I can intervene when the agent starts to drift in the wrong direction. Let me explain why I care so much about the token usage. In February, I did a comparison between Cloud Code and my in-context prompting approach. It was a new project, rather small. I spent a total of 12 hours working on it. 10 of them used the in-context prompting approach, and 2 hours I used Cloud Code, which was released just a couple of days before. And in that case, I was using Cloud Sonnet 3.7 in both cases. And initially, I started the project with the in-context prompting approach. Then Cloud Code was released, so I tried it out, and I've used it for about 2 hours, where I've had to wait quite a lot for it to actually do something. In the end, it actually destroyed all its progress with a git reset. And the token usage really speaks volumes here, because Cloud Code had to navigate the project on its own, and it tried to understand the code just from what it found. And for this reason, it used almost 10 times as many tokens per hour. And because each token costs not only money, but especially time, and not just its generation time, but me waiting for it to do something, the decision to abandon Cloud Code was quite clear back then. So is my recommendation to just use the in-context prompting approach with cursor? Well, no. The advantages of the agentic approach with Recode with the newer Claude 4 Sonnet outweigh for me nonetheless. Only the waiting time is still bothering me. So what to do? If more autonomy is so slow precisely because of navigation and code understanding, then I can dial it back a bit. At Express AI, we've dubbed the approach Omega programming. We still use an IDE AI agent, but apply some of the principles of extreme programming. In particular, the pair programming process, as defined in extreme programming, helps us here. By having the AI take the position of the driver and me take the position of the navigator, we get a harmonious and efficient collaboration. Just like in real rally driving, it's the driver's job to implement the navigator's instructions. And the instructions are very specific, like in 300 meters, curve 90 degrees left. Additionally, comes the idea of collective ownership. Everything is our code. There is no distinction between my code and AI code. I take full responsibility. Concretely, this means that in every instruction, I provide the complete context. I reference the files that need to be read and edited. I mention which architecture decision records are relevant, and I also set the general rules that apply to the project. This makes me a necessary and integral part of the process. I actively bring in the mental model and ensure that the generated code continues to fit it. In return, everything goes significantly faster because AI doesn't have to search for additional information itself. Due to due to the fundamentally agentic functionality, this still consumes more tokens than the in-context prompting approach in Cursor did, but I still get the diff for the review step almost immediately. This makes the Omega programming approach pretty much the exact opposite of vibe coding. As an Omega programmer, it's not enough for me that it just looks like it works. I need to understand exactly how my code works and why it is the way it is. And because of that, I can answer the why questions and also explain why other approaches weren't used. And with this, let's take a step back to the original question. Can a 10x developer become a 100x developer with AI? If we only measure by lines of code, then the answer is obvious, yes. Even a 0.1x developer can become a 1000x developer on that metric. But as explained at the beginning, code alone is and remains a liability. The mental model is the real value. How does AI then help us to improve the mental model? First, we can use AI to get up to speed on a topic faster. By approaching research work with AI, a crystallization point for the mental model can form. We can, for example, better illuminate the so-called unknown unknowns, find ideas that we wouldn't even have searched for ourselves. By using AI to quickly generate prototypes, you can work side by side with an end user to better understand how the software can ultimately be used. You use the description and the prototypes to solidify your mental model and share it with the team. When working in an area that is already well understood, but each customer still has special wishes, you can also have the AI generate code in a domain-specific language. From this, you can then deterministically generate code that by definition fits cleanly into the overall picture. Especially together with the idea of rapid prototypes generated side by side with a customer, this is where the potential for the 100x developer is most likely. You essentially produce your own vibe coding tool, only that now you understand exactly why the code is the way it is. And finally, daily work can also be accelerated somewhat by using AI very specifically. Here, you don't necessarily get a 10x multiplier on average, but you don't have to. In my experience, AI affects developers more as an exponent than as a multiplier. A good developer can get better, but a bad developer will also quickly get even worse. Will a 10x developer now become a 100x developer just with AI? In brief moments where AI usage improves not only development work, but especially communication, a big gain is possible. But on average, no. Somewhat faster is possible, but if you want much more, then that also requires much more than just AI assistance. Writing code was never the real bottleneck in software development to begin with. If it had been, then the best developers would be those who can type the fastest. No, it usually depends on understanding the problem and how it could be solved, and also on communication in the team and with the end user. AI can help here and there, but it doesn't make all of those problems 10 times easier. There is another problem that AI could at least temporarily help us with. It's hard to distinguish quickly a good developer from a bad one. Maybe we can listen for a while to exactly who supports their arguments with "because ChatGPT said so" and get an answer that way. And with that, we're at the end of the talk. Thank you very much for your attention. If you want to discuss the ideas or want to learn more, feel free to reach out to me on LinkedIn or send me an email.